the interruption video just now, so I continue with another video. I don't want to combine it together because it will take long and the file will become larger. So I continue with the next video, which is continue from what we have learned on our point-to-point mode. So now it's under your sending and receiving message. The basic function for send and also receive, this one you already learned. Send and also receive. I change the color. Send and also receive. But understand also you have a lot others. If you go back to this, I think not here, it's okay. So back to our main slide, you will notice that you have the MPI send and also MPI receive for your message when you want to perform the exact activities or program. So MPI send, the data store will be in a buffer. If you are, let's say you will send to the receiver, when you key in anything and it will be stored in your buffer, right? And then after you click send or you perform the send for under MPI, then the message will be delivering to the receiver. And then under MPI receive, it will receive a message sent by the processor, which is it will return to the sender only. You can see over here after the message has been received and copied into a buffer. So this is the example of coding when you want to send and also you will receive on the receiver from the sender. So let's say you have R0 and then R1. So you want to send your data or your packet from your R0 to R1. So this is basically the example of programming. You can check it, and maybe you can try also to run in your computer. Try to look into what is the output and etc. If I check here, everything is okay. Yeah, this coding is okay. And you will have the exercise, but please ignore it first. I will do it the exercise with you later. And you can see also there is another exercise. We will do it as our lab 2. So just focus in our theory in this video. So next what we cover is under wildcarding. So you can see that under wildcarding, in some cases or some process, you may need to receive message with a wildcard mode. If you have taken the datacom, you already learned on this term. Let's change color. Okay, you learn on this term, which is under wildcard, which is you follow a certain criteria. So it is not by default, but it is assigned while using a wildcard from any source. So from any source in MPI with using MPI dash any dash source. And also another one is with any tag number. MPI any tag. So this is implemented by applying the MPI any source and also MPI any tag in your MPI receive function. So this is the example, which is you have the source and also you tag it to apply it here. Under your informations in MPI status data type, so you have the receiver process may find out that sender process ID and message tag number of the communication from your MPI status parameter of the MPI receive function. Status normally for MPI source, and then it hold the rank of sender, which is your source ID, of course, process the communication. And another one is for the status and the MPI tag, it hold the tag number of the communicator. So you can check over here, this is MPI status and this is the parameter here. So you might see that there is another coding on programming under MPI. So you can also try to run it, but I will show you also in our lab later on. Measure the program execution duration. So it is a record the beginning and the finish time using the double MPI W time, which is for recording your finish time and etc. So this is the example of the coding. And when you run this coding, you're going to get your output. I hope that you will get the output, and please check on the sleep durations whether it's similar or not. Then we'll go into the blocking and non-blocking. As repeat again, we have two types, which is synchronized and unsynchronized. Now we look into the blocking and also non-blocking. So normally in implementing the blocking communication, result processes in block. So it also can be said as a waiting stage. And then in some cases, better to allow process to do next instruction without have to wait for a communication to complete, of course. Then therefore, implementation of non-blocking communication is a solution for these cases, which is without having to wait. Non-blocking is the solver. And the non-blocking communications functions in MPI allow to proceed with next instruction, which is for non-blocking, and then it's check its completions sometimes later. So first, in non-blocking communication, still it was under your blocking and non-blocking. So here you can see on your non-blocking communication, they are separated into three phases. Phase 1 is indicate non-blocking communication. Phase 2 working on their operation, which is it is not a must but it is optional. And phase 3 is a complete the non-blocking communication. So under non-blocking communication function, you can see when you run it what happened to your programming. So you need to follow that there is a phase by phase. So that's why you will looking into this. We is for the first step, you initiate the non-blocking communication. You will get like this is the coding. And then for the step 2 not yet covered, this is under your phase 1, which is you initiate the non-blocking communication. We are still under non-blocking, and non-blocking. First is under standard send, and then synchronized send. Next is buffer send. Lastly is a ready send. So you can check the command that used for the MPI for each communication type under non-blocking. And then you have the phase 1 under MPI under non-blocking and blocking, which is initiate the non-blocking communication on the receiver side. So you can see for the receiver what is happening. And phase 2, which is working on other operations, the main purpose of implementation non-blocking function is to allow the process, either the sender process or receive process, to provide others operation instead of begin block and also begin wait, or maybe it's queuing at the communication operator. And therefore the others operations supposedly be implemented in this phase. However, this phase is optional, as I mentioned in the step 1, 2, 3. There is a phase 2 which is optional. Status of the communication operation is unknown during the phase. And lastly, the phase number 3 on the completing the non-blocking communication operation. So you can check. Let me change mine. I want to just. Okay. So where are we now? So under this phase 3, which is the last phase. So since status the communication initiate in the phase 1 is unknown and resources allowed to the communication is not released yet, therefore it is a requirement to complete the non-blocking communication. I think until that only for this video first, or maybe I can just cover it. Let me finish, so then on your synchronized class, so you can have touch for the next section 6B. So for non-blocking communication, which is test function allow the process to process the other operation, which is right after the initiate the communication, and regularly check the status of the communication. This is under non-blocking test. And please take note also, the flag is a Boolean variable. So basically a Boolean variable, you can have A until Z, something like that. This is the examples. So the flag true means the communication have completed. Under the non-blocking communication, for the wait function are used when the process has no other operation, you can see over here, to do, or it's ready to wait. Either one, whether it is no other operation or it ready to wait for the communication to complete. So this is under wait and the calling wait function just after initiates the non-blocking communication phase 2 is equivalent to the blocking communication. It is unblocking, you can see over here, but when you have the function of wait in non-blocking communication, it's similar to you assign the communication to the blocking communication. So the example is MPI I send, MPI send, MPI wait. And then on non-blocking communication for the request, which is MPI request free, use to abort the communication and release the resources. You stop directly. This is the example. As I said, you might try it. And this is the example of output when you try to run this coding. And you have the exercise you might try, but I will think about our lab 2 later on. So in this video I already covered the module 6A, and in class we will directly continue the module 6B. Thank you for watching and have a good day. Bye bye.